deriving the point-slope equation of a line and transforming to standard form. Here's a question I came across. Finding a linear equation ax plus by plus c equals 0 given 2 points. If you have 2 points, for example P and Q, you can find the linear equation of the line that passes through those points in the form ax plus by plus c equals 0. That's standard form, of course. You can do that in one easy step by simply using the formula y1 minus y2, which is the coefficient of x, plus x2 minus x1, which is the coefficient of y, plus x1 y2 minus x2 y1, which represents the constant, and all of that's equal to 0. So to reiterate, the question is, what is the equation of the standard form line that goes through the 2 points minus 2, 1 and 10, 7? Standard form, of course, refers to equations in the form ax plus by plus c equals 0. So we're looking for the coefficients a, b, and c. So if we graph this line with the 2 points, one way we could do this is to rearrange it in the form y equals mx plus c, and then substitute minus 2, 1, where x is minus 2 and y is 1, and 10, 7, where x is 10 and y is 7. That would give us the 2 equations below, minus 2m plus c equals 1 and 10m plus c equals 7. And solving those as a pair of simultaneous equations, we'd get m is equal to 1/2 and c equals 2. That's easy enough, but we're going to do it a different way. Before we ultimately solve this the way that we're going to try it one other way. ax plus by plus c equals 0. Let's substitute those 2 points in. Minus 2, 1. That gives us minus 2a plus 1b plus c equals 0. Let's call that equation 1. 10, 7. That gives us 10a plus 7b plus c equals 0. Let's call that equation 2. Treating those as a pair of simultaneous equations, first of all, let's eliminate c. Well, we can do that by subtracting one equation from the other. So let's subtract 1 from 2. That gives us 12a plus 6b is equal to 0. And the result of that is minus 2a. Let's multiply equation 1 by 5. That would give us minus 10a plus 5b plus 5c equals 0. Using equation 2, which was 10a plus 7b plus c equals 0, and adding those two together will eliminate a. That gives us 12b plus 6c equals 0. Now, if we solve that for c, we get c is equal to minus 2b. We have b is equal to minus 2a, and c is equal to minus 2b. Minus 2 times b is just positive 4a. Substituting that into our original equation of ax plus by plus c equals 0, we get ax minus 2ay plus 4a equals 0. Now dividing through by a, x minus 2y plus 4 is 0. That's the equation of our line in standard form. Changing that to slope-intercept form, we get y is equal to half x plus 2. So a line can be solved if we have 2 points and it's in standard form simply by manipulation. Going back to our graph of the line, rather than using the 2 specific points minus 2, 1 and 10, 7, let's treat those endpoints generically. We'll call the lower one x1, y1 and the upper one x2, y2. And we'll have a general point which ranges between those, which we'll call x, y. Gradient is simply rise over run. So how do we measure the gradient from the lower specific point, x1, y1, up to the general point, x, y? We take the difference in height, which is the rise, which is y minus y1, divide that by the run, which is the difference in our x values, x minus x1. M symbolizing the gradient, is equal to y minus y1 over x minus x1. We have m is equal to y minus y1 over x minus x1. Rearranging this, we get point-slope form of a line. Y minus y1 is equal to m times bracket x minus x1. Remembering that m is the slope of a line, if we now consider the slope between the 2 specific points, x1, y1, and the upper point, x2, y2, m is the rise over the run, y2 minus y1, and the run is x2 minus x1. So that m becomes y2 minus y1 over x2 minus x1. That gives us our third line. Rearranging this, multiplying both sides by the denominator, x2 minus x1, we get a fourth line. x2 minus x1 times y minus y1 is equal to y2 minus y1 times x minus x1. Rearranging that so that we have an equation which is set to equal 0 gives us the bottom line, which is x2 minus x1 times y minus y1 minus y2 minus y1 times x minus x1 all equals 0. So starting from the previous page, we had x2 minus x1 into y minus y1 minus y2 minus y1 into x minus x1 equals 0. If we change the order in that third bracket, so instead of y2 minus y1, we have y1 minus y2, that effectively negates that quantity. The equivalent statement is now x2 minus x1 into y minus y1 plus y1 minus y2 into x minus x1 equals 0. Multiplying out, we get x2 minus x1 times y plus x1 y1 minus x2 y1 plus y1 minus y2 times x plus x1 y2 minus x1 y1 equals 0. Rearranging that into standard form, we have the coefficients of x and y and the constant. So we get y1 minus y2 multiplied by x plus x2 minus x1 multiplied by y plus x1 y2 minus x2 y1, all equaling 0. So that shows ax plus by plus c is equal to 0 has coefficients a equaling y1 minus y2, b equaling x2 minus x1, and c equaling x1 y2 minus x2 y1. If we go back to the second slide, we can see the line down the bottom is exactly the line that we've just derived.